Welcome to qnawire.
Alright, so in this problem we have a block of ice on a nice, smooth, horizontal, frictionless floor. We know the mass of the ice, and then a dock worker is applying a horizontal force to that ice block. And we know the values of all of these things. We don't know what the mass is. That's what we're solving for in part A, but we do know what the applied force is. It is 80.0 newtons. And then some information, because we're doing a little experiment to figure out what the mass of the block is. It moves 11.0 meters in a time interval of 5.00 seconds. Great, fantastic, and then we can actually begin part A down here. Yeah, so we know that it's experiencing a constant acceleration. So in order to solve for the mass, we'll have to first find the acceleration. We have information about the displacement and the time interval, so it makes sense to use this kinematics equation, the one involving the time squared. Excellent, excellent. And then lastly, one other piece of information that was given to us was that the block begins from rest. So that first term on the right-hand side is going to be equal to 0. So now we can rearrange this kinematics equation in order to solve for acceleration, which is 2 delta x over, I believe, time squared. Alright, so we are ready to plug in numbers, namely 11.0 meters, and then 5 seconds squared. Don't forget about the square. And then we see that our acceleration is going to be equal to 0.880 to 3 significant figures, meters per square second. Good. Let's draw a little line here. Now, oh, sorry, that wasn't the final answer, but it is important for getting the actual final answer. The last thing we need to do is apply Newton's second law, but rearrange it in order to solve for the mass. So it's going to be F divided by, F divided by A. Just a couple things I'm going to fix here. And we now have all that information because we solved for the acceleration. So 80.0 newtons, and then a very similar looking number, 0.880 meters per square second will give us a mass of 90.9 kilograms. So 3 significant figures. Okay, and now we can move on to part B, where over the course of the next 5 seconds, how far does the block travel? So we're going to call this second interval delta t prime. And then what we're solving for is this second length interval of delta x prime. So it's going to be a big question mark. So just to be really explicit about the information that was given to us in the previous part of the question. Remember the initial velocity we said was equal to 0. And the final velocity is something we're going to have to solve for first in order to figure out what that second distance was. So the equation that we'll want to use is the equation involving the square. We actually have a choice of equations, but I think this one would just be the easiest to get the information that we need. As we said earlier, the initial velocity is equal to 0, so that term is going to go away. And then we can get that the final velocity that we need by taking the square root of both sides. Alright, so now I can plug in some numbers. So the acceleration that we found was 0.880. Multiply that by delta x, which was 11 meters. And then get that the final velocity was 4.40 meters per square second. And then we can solve for that interval because it's now moving at constant velocity since the force is no longer being applied. We just multiply the velocity it's moving at by that time interval. So that's 4.40 being multiplied by 5 seconds. So that gives us a length interval of 22.0 meters to 3 significant figures.